Hello, this is a very quick introduction to Entwine, which is our uh, browser-based tool for constructing error correction codes and error correction circuits. Um, so what we're presented with is, in the first view, we have these two uh, tabs here. On the right, I have some simple instructions on how to use Entwine and its basic commands. And on the left, I have the basic lattice upon which I'm going to define my logical qubits, stabilizers, and logical operations. This lattice is essentially infinite, so if I keep scrolling, I can just explore it forever. I can also zoom in and zoom out easily just using the standard keyboard or mouse actions. So the basic operation is going to be placing stabilizers on this lattice. And the way I do so is using mouse or touchpad actions. So I'm going to click and drag to get different stabilizers of different sizes and shapes if I want. At the moment, I'm going to show everything's kind of rectangular shaped stabilizers, but later on I'll show some freehand mode drawing where you can place different shaped stabilizers. The difference between the colors is, of course, the type of stabilizers. So the orange colored ones are X stabilizers and the blue colored ones are Z stabilizers. I can place an orange colored stabilizer by with a left click of the mouse and drag, and the blue colored stabilizer, which is the Z stabilizer, would be placed with a right click of the mouse and drag, or you can alternatively hold shift and left click. So let me clear all of these. So I can define anything I want. I said that there's this freehand mode, which actually I access this by pressing F on the keyboard here, and I can draw stabilizers of strange shapes or at least non-rectangular shapes if I like, and this could be useful for defining new quantum error correction codes with any kind of stabilizer pattern, any kind of stabilizer definitions you might like. But let me focus specifically on the surface code. So surface code, I'm going to build a rotated surface code patch, a distance 3 rotated surface code patch, which practitioners will recognize. I made a mistake there. This is basically, I'm almost finished. At the moment, this is just a definition of stabilizers, but as soon as I add the final stabilizer to this patch, it will recognize that it is a surface code patch. This green box has appeared around the logical qubit now. That tells me that it's one of the recognized error correction codes within Entwine. The two that are supported at the moment are the surface code and the repetition code. So for example, if I were to define a repetition code qubit, here's just a very simple one, it would also put a green box around that, and that would tell me that there's a recognized qubit type there, in this case belonging to the surface, the repetition code, in this case belonging to the surface code. Let me remove the repetition code one and just focus on the surface code. So what I can do, I have one surface code patch here. Suppose I want to make a copy of it. Command C, just drag, Command V, tell Entwine where I want to place the second copy, and there it is. So now I have two surface code patches side by side with a row of unused qubits between them. What I'm going to do now, the fact that I'm in surface, it recognizes these are surface code qubits, I can access the machinery of lattice surgery, the operations that are known as logical operations on those logical qubits of the surface code. I do this by pressing S on the keyboard. So previously, all the mouse actions I showed were defining stabilizers, but when I enter surface lattice surgery mode, all of the mouse actions are going to be interpreted as lattice surgery operations. You'll see that in a second. Here on the right, this is the Loom code for setting up these surface code patches with their corresponding positions on the lattice, etc. They've each been given a name. There's some basic operations which are always added here. But if I want to add a new operation, suppose I want to merge these qubits together into a larger surface code qubit, I can do so. I press E on the keyboard. Oops. I press E on the keyboard, not in this window. In this window, I get the addition of a new frame of operations, and if I select this, the qubits belonging to these qubits and the logical patches and the space between them, it will interpret this when I release the mouse as merging the qubits together. You see, so a merge operation has been inserted there. I could add a second, I might want to do something else where I then split the qubits apart again, and that would be achieved simply by selecting the qubits, these physical qubits which sit in the middle of the two logical patches. And you would see then the split operation appears. But let me undo that and just stick with the merge operations for now. So I'll just leave it as creation of two qubits, logical patches, and then they're merging together. Okay, so that's what we see. Now, the last thing I might want to do is to measure this joint patch. So let me do that. If I simply right-click and drag across the entirety of this patch, this is going to be a Z logical measurement. If I wanted an X logical measurement, I would use a left click. This is a right click, so it's going to be a Z logical measurement. Sorry. Okay, so then the measure logical Z instruction has been added, and the patch kind of disappears because it's now been measured. Now I move over to the Run tab. This is where I have the ability to actually run the circuits and the experiments corresponding to the operations that I've defined. So again, I have the Loom code. I have in this middle window the STIM code. I can look at the CHASM code as well, or the ECA code, which is the underlying language for Loom, where circuits sit. And over here on the right, I can simply use an interface very similar to the kinds of parameters I would specify, say in STIM or standard workflows. I want to run the circuit that I've defined with some physical error rate, and I might want to look at what the logical error rate is. So I can run this. This is running in STIM in the back end. I can run this for different physical error rate values. I'll just take 3 for sake of demonstration. So I've run these. I have the data that I need. Now I can go over to this graph tab here in the top left. I click on graph, and now I can see what it looks like to plot the logical error rate versus the physical error rate. And I can explore this in log or linear form. This is the basic functioning of Entwine. There are many other things I can do. I can change the distance of the experiment simply by changing the distance here. I might also want to change the QEC rounds. If I go up to distance 5, I could run this again, and it would get the same. It would run exactly the same sequence of experiments as I defined, just for distance 5. There are many other functionalities, of course, for usability. So I can export the data, the circuits. I can export the data that has been defined here simply by clicking the export button. I can import Loom circuits, and I can import data as well using the import button. But this is the basic functionality of Loom. And once I'm complete, everything I want to do has been done. I can simply hit reset, and this will clear absolutely everything, and I get back to the start again. And that is Loom, that is Entwine, sorry, in a nutshell.